Welcome to AEC Example number 12 from the Cat 1 Structures Study Guide. And I'm going to start, actually I'll tell you what they want to know first. The cable shown has a diameter of 3/4 inch and supports a load of 10,000 pounds. What is the unit tensile stress in the cable? So they're looking for tensile stress. What is tensile stress? First thing you need to do is go ahead and do a free body diagram. And you want to take those and go ahead and throw it on there. So I would just say a free body diagram, it's pretty much a free body diagram as is, but a true free body diagram doesn't have, the connections or whatnot. So you just want to say, oh, okay, this is coming out right there, and that's 10,000 pounds. And this is 10,000 pounds. Now it might be confusing to say, oh, well, it's 10,000 pounds, and 10,000 pounds, you're seeing 20,000 pounds force in the middle. But that's not true. It's more of an equal opposite, and it's equal and opposite reaction here. So to understand it exactly, I want you to cut this. Go ahead and cut it like you would when you want to find the stress in the middle of a beam. You want to go ahead and cut this. So cut it anywhere along here, but we'll just cut it right in the middle. It does not matter because this is tensile. So when you cut it, well, you could, knowing that you're an engineer or an architect or a smart guy, you have this. Well, this is your cut, and then you have 10,000 pound load. Tensile load coming out, and you have a moment. Well, there's no induced moment. This is, so the moment equals 0. This, we'll call it V, or the shear, equals 0 because there's nothing to act against it. It doesn't have to resist anything. So there's only tensile strength, or tensile resistance here, a tensile load that you need to do equal and opposite. So that is going to equal 10,000 pounds, which you might call a tensile load a P load. So I'll say P equals 10,000 pounds. So now you know, oh, okay, well, the load inside here is 10,000 pounds. Now you want to go and find the unit stress, which unit stress, is, excuse me again, take P over A. Some people do F. That's stress. There's a lot of different things that people go ahead and do it, but I'll use the F in this case. So it's P over A. And we know P, which is 10,000 pounds. And A equals what I say. And it is the area of the cross section, which the cross section looks like this. It's a steel bar or steel wire or whatnot, and it's 3/4 inch diameter. That means diameter. So the radius is what? 3/8 inch. So to find the area, I hope you know this is pi r squared, or some people say pi d squared over 4, I believe it is. Let's go ahead and do what we were all told in elementary school or junior high, pi r squared. So pi times 3/8 inches squared equals, type it into the calculator, pi times 3/8 squared equals 0.442. And since we're squaring these inches, it's inches squared. So let's say, okay, this equals 0.442 inches squared. 10,000 divided by 0.442 equals 22624. And that is in pounds per square inch, PSI, or you could do pounds per inch squared. A lot of people just do PSI. And that is a stress term you'll see a lot. A unit stress is PSI. We'll go ahead and check this and make sure we did it correctly. And he is 22,640, which is close enough. He took this to 0.4417, but 22,640, what you'll typically see is this will be equal to 22.6 KSI, and KSI is what you'll use, but this is what they got in the example.